Okay, so hello and welcome to today's lesson. I actually want you to do the do not problems. So there are like actually 2 do not problems that we have in here. I'm going to give you approximately 4 to 5 minutes to do the 2 problems, and then we are going to go over them.
All right.
So for the do not problems, you are supposed to simplify them, and the way that you are asked to do so is by multiplying. So you are essentially doing multiplying rational expressions.
Okay.
And remember, just as a review from our previous lesson, to multiply them, you have to simplify the top. By simplifying, I mean factor. You have to factor the top, factor the bottom, do the same thing to the other expression that you have in here, or rational expression rather you have in here. Factor the top, factor the bottom, and then find the common factors, cancel them out, and then you have your answer.
Wait, can I not cross multiply?
So you mean like multiply like this?
Yeah.
Okay, you can't. Okay, when you are like multiplying, right, expressions and not equations. So when you multiply equations, that meaning that you have like an equal sign in between, right? The two rational expression. That is the only time you can actually multiply them across. But if not, then you can only multiply them sideways like this.
Okay.
But you can cancel things across. So like, let's say you have something in here that you also have down here. So if you have two common factors across, you can cancel them out. You can also cancel like up and down. You can cancel across, but you can, like, if you're talking about a multiplying, you can only multiply sideways like this. But you can, if it was instead of an expression, if it was a rational equation, and then if you were asked to solve for x, then you would multiply across, like cross multiply. But for now, you can't do that because these are expressions.
All right. Wait, so like the x on the first one, I can if I multiply with the x on the second thing, the second, I forgot what's it called, second x square, I'm gonna get x3, right?
So are you trying to like multiply this expression with this one? Like, are you're trying to like multiply these two polynomials? Well, if I remember correctly, I mentioned it in our last class. Please do not try to do that, because you're just going to make it more complex. Because if you multiply them, right, if you multiply them like that, right, you can work your way through that. But the problem is going to be you are just going to end up with a more complex polynomial. And remember, the only way you can simplify a rational expression is by factoring. So if you multiply like this, like sideways, right, you are going to end up with a complex polynomial, and then you'll have to figure out a way to factor that, and then you'll have to figure out a way to find the common factors, and then you cancel them out, and then you are left with your answer. But instead of doing that, instead of multiplying, which is like, I know it's like super tempting to do that, because that's what you would do if you had like numbers instead of like numbers and variables in expression form. Okay, let me walk you through. Okay, so we are going to work on this together. Okay, so we are going to do the first problem first. So let's look at this. This is the top part. So this is actually a binomial. So you have x plus 7. Now you ask yourself, hey, is this factorable? Can I factor this any further? Is this factorable, Zarif?
No.
You cannot factor this anymore. So, okay, if I can't, then I can't. I just leave it like it was before. Now look at the bottom, right? Because, okay, here's the thing. When you are asked to multiply rational expressions, you work your way like, kind of like chronologically. So you do this part first, and then you go to the second fraction. Okay, so you do the first fraction, and in the first fraction, you do the top first and then the bottom. Okay? So then you ask yourself, is the bottom factorable? Can you factor the denominator you have in there?
Yes.
How can you factor that? Using what method, I meant?
Like dividing 35 with 5 or with 7, and you get like you can divide 35 by 5 and like simplify it.
So okay, remember, so you have, what you have in there is actually an expression. So whatever you do to 35, you have to do the same thing to 7x. So if you are telling me that you are going to divide 35 by 5, remember you also have to divide 7x by 5. And if you divide 7x by 5, you are not going to end up with a whole number. You are rather going to end up with a fraction. We do not want fractions.
I can do it to 7, right?
Yep. So which is called the Gcf method of factoring. Okay. So you are on the right track, and I'm glad you are. So you are going to ask yourself, what is the GCF? So 7x plus 35, what is the GCF? The greatest common factor. In other words, what is the greatest monomial that divides into both of these terms evenly? Well, I know that the GCF, like I have been saying, is not going to have a variable with it. How do I know that? Well, I know that because only the first term has a variable with it. The second term does not have a variable, so that is an x. It cannot, the GCF cannot have a variable with it if the second term, or if all the terms do not have a variable with them. So my GCF is just going to be a plain number. It's just going to be a constant, okay? So then 7 and 35, what is the GCF?
1x and 5.
You said 1x?
My bad. You divide 7x by 7, you get x, and 35 by 7, you get 5, right?
So you are actually on the right track, and you skipped a step, which was what I was asking you for, the GCF. The GCF from whatever your explanation was is 7. That's correct. 7 is the greatest number that divides 7 and 35 evenly. Okay, so that's correct. You did it correctly. So now you figured out GCF, and you also know that you have to divide each of the terms using 7, and you already told me this step, which is like you divide 7x by 7, 7's cancel out, you are left with x, and if you divide 35 by 7, you get 5. So I'm just going to write plus 5 because that was the sign before 35. So this is the factored form of this right here, the denominator. So I'm going to put it here, okay? Now let's move on to the second ratio or fraction that we have. We have to do the same thing in here, okay? So what do we have to do? For the top and the bottom, what do we have to do?
We can divide, factor them.
Factor them, yes, factor. That's the key word. We have to factor the top, and then we have to factor the bottom. Let's factor them. What kind of factoring do you have to perform for the top?
Gcf.
Okay, and now ask yourself, what kind of polynomial is that? You can determine polynomial by seeing or by looking for the number of terms. How many terms do you see in there?
2.
You see 2 terms, so this is 1, this is 2, this is 2, and you're just gonna leave the 40 out, the negative 40 out.
I thought it was like the x's.
Oh, you thought it was this?
The x's. I thought those are called terms, but 3, I guess.
Oh, no, this is a term right here. This is another term right here. This is like a constant. So x squared, that's a term. Negative 3x, that's not a term. So I asked you how many terms are there in the first, not the first, but in the top. How many terms do you see?
On the bottom, 1.
No, I was asking for the top. This. How many terms do you see in there?
3.
3, right? So if it's if it has 3 terms, that means it's what? A trinomial, right? And if it's a trinomial, what kind of factoring did we learn to do with trinomials? Trinomial factoring, yes, Zarif, you're correct. So we are supposed to do trinomial factoring because I see 3 terms in there, okay? You cannot do GCF for this because x squared and negative 3x, negative 40, they do not have anything in common, right? I mean, the only term or the only number that I would say they have in common is 1, but we're not looking for that, okay? So what we have to do is like do trinomial factoring, which is something that we all love so much. Okay, how do we do trinomial factoring? I know you're already sick and tired of this, but it is what it is, okay? So how do we do trinomial factoring? Should I give you a hint, clue?
Yeah.
Okay, so the first thing that you do is you look at the variable. What is the variable for this expression?
X.
So you put the x as the first term of your 2 factors. This is a factor, this is another factor, okay? So you put x, right, as your first term in both of the parentheses, and now you're telling yourself that that is my first factor. Now, first term, sorry. Now you are supposed to find what is the next thing that you're supposed to find or supposed to like look for?
The number.
The 2 kind of like magic numbers, I would say. So if you actually add the 2 numbers, you are supposed to get -3. And if you multiply the 2 numbers, you are supposed to get -40. Remember, you are bringing the coefficient of the middle term, and you are supposed to bring the sign with it. So whatever sign it had, you have to bring it here. And the same thing for the constant term, whatever sign it had, you have to bring it here. If it's a plus, we usually don't write it in front, but if it's a minus, then you have to bring it here, okay? So then what are the 2 numbers that if you add, you are going to get -3? And if you multiply the same 2 numbers, you get -40.
-1 and +2. No, -1 and -2. So it's gonna become negative, because the plus makes it, and it still makes it a negative if it has -2. Does that make sense?
So wait, so then what are the 2 numbers?
-1 and -2.
So they give you -3. So the first one checks out. If you multiply -1 and -2, do you get -40?
No.
Well, then those probably are not the 2 numbers then.
Wait, can I like subtract 40 with -3? -40 with -3.
Okay, so I apologize if I'm making it too confusing for you. So what I'm actually asking you is that what are the 2 numbers, right? It does not matter if they're 2 negative numbers, 2 positive numbers. If you add them, you should get -3. And then if you multiply them, you get -40. So here's the thing. When do you get negative products? So like if you multiply 2 things, when do you get a negative product?
When the 2 numbers are negative.
So you are telling me that if I multiply -1 times -1, I get -1?
No.
Do I get -1?
Yes.
-1 times -1 gives you -1.
No, my bad.
Negative times negative gives you a positive.
Yeah, I forgot.
Right? So if that's the case, I know that a positive times positive gives me positive, negative times negative gives me positive. So then what does a positive times negative gives me?
Positive times negative. It's negative.
Right? So I know that if I'm looking for -40 right here, then I know that one of my numbers has to be negative, right?
Yeah.
So I'm going to put negative here. And if one of my numbers is negative, what is my other number going to be?
Negative.
Look here, down here.
If one of the numbers are positive, it's gonna, and you
If I already put a negative in here, right? So if one of my numbers is negative, what is my other number going to be?
positive.
Yep, you got it. The other number is going to be positive. So now I know my variables and I know the signs, right? So now what I'm asking you is that there's going to be a positive number and there's going to be a negative number. And now I'm asking you, what should those two numbers be such that if I add them, I'm going to get -3, and if I multiply them, I'm going to get -40. Here's something that I kind of like to do when I'm asked this question or when I have to do trinomial factoring. What I do is like I try to find the factors of 40.
Okay.
So what are the factors of 40? So you have 1 times 40, that gives you 40, right?
1, 2.
2 times 20. And what else?
2 times 20, then 4 times 10.
What else?
5 times 8.
Oh, okay. So let's just stop here. 5 times 8. Now let's ask ourselves, if I do something, if I add, subtract, or whatever I do, can I ever make 1 and 40? Or if I do -1, +40, +40, -1, can I ever make them equal to -3? Is that even possible?
No.
That is not possible, right? So now let's see if 2 and 20 works out. If we subtract 2 from 20, do we get 40?
Subtract 2. Subtract 2?
Yeah, subtract 2 from 20. Because what I'm essentially asking you is that, can
Yeah.
you do something to these two numbers so that they will give you -3? You can add them, subtract them, make one positive, make another negative. I mean, can you ever get -3?
-3?
Yeah,
No.
like, okay. Now here's another thing. I already told you that one of the numbers is going to be positive, the other one is going to be negative. So you know that you have to subtract one number from another. So let's keep it with that, okay? So let's look at 4 and 10. If you subtract 4 from 10, do you get -3? Or if you subtract, yeah, if you subtract 10 from 4, do you get -3?
No. But
Nope, you don't.
the 8 will work.
Yep, 5 and 8 will work. Because if I put, and then here's another thing. Once you figure out the two numbers that you know will give you a product of the product that you are looking for, and will add up to the number, the middle coefficient, you know that the bigger number goes in the first parenthesis.
Okay.
Does that make sense? -8 plus 3, right? So -8. Sorry. I meant to write 5 here. -8 plus 5, does that give you -3?
Yeah.
Check. Does -8 times +5, does that give you -40?
Yeah.
Second check. So those are actually my two numbers. So the best way I think to go when you are doing trinomial factoring is like to find the factors of your constant term. So whatever your constant term is, right? So like in this case, it was like -40. You ask yourself, what are the factors of -40? Instead of trying to like add like, random numbers and then get them to work for the middle coefficient, you can always like look at the constant term and then try to figure out what are the factors and then what can I do to those factors to make them look like the middle coefficient, okay? So I already factored my top, so I'm going to write the factors here. I have x minus 8, x plus 5, and what do I have to do to the bottom? Or is there even anything that I need to do for the bottom part? Nope, I don't. they were nice enough to give me in the factored form. Now what do I have to do?
Multiply them?
Yup, we have to, do we multiply them? Remember, we are trying to like make it simple because it literally is like simplified. If you are multiplying, then you're just going to make it more complex. So, let's just keep it simple and simplified. So now what I have to do is look for common terms. Do you see any common terms? Name them. So if you are trying to identify common terms, you have to look for them both in the denominator and numerator.
X.
And?
Can I say 7 on the first one?
Okay, so you cannot tell me that X is a common term because you have X in here, you have X in here. You cannot do that because that X is in an expression. That X is not by itself.
What about 7?
Right? You can tell me about this 7, but you can't tell me about this 7. Because that 7 is literally added to X. You cannot like split them up. So what?
-8.
Okay, here's the things, right? For this, I cannot like, okay, so if I have something like this, and if I have something like this, I cannot cancel out the X and I cannot cancel out the 8. That is not right. You know why that is not right? Because this is an entire expression and this is an entire expression, and I can only cancel out expressions if they're identical. If they have the same sign, same variable, same numbers. So if everything is the same, then only I can cancel them out, but I cannot cancel out their terms individually. That does not work. So what you have to do is that do not be disappointed because we actually do have common terms. Where do I see common terms? Okay, I don't see anything in here. I don't really see anything in here. So when you are looking for common terms in rational expressions, you look for expressions. You look for if you have x plus 7 in other places. Do you have x plus 7 in any other places other than here?
No.
You don't, so it does not, you do not have a common factor for x plus 7, hence it will not cancel out. Do you have any expression that has any other expressions that have 7? Just 7, nothing added or nothing added to it or subtracted from it?
No.
No, right. So 7 does not have a common factor. It's not going to get canceled out. Let's check for x plus 5. Do you see how I am taking like them in kind of like pairs? If it's a binomial, then I'm taking the entire binomial. I'm not looking for individual terms to cancel out. So x plus 5, do you see any other x plus 5s?
Yeah.
Where do you see another one? Here, right?
Mm-hmm.
So I'm going to box them because they are my common terms. How about x minus 8? Do you have any other expression that looks identical to it?
On top.
Yep, that's correct. There's one at the top, there's one at the bottom, and you can't cancel stuffs up and down. So that actually works for us. There, now we do the most satisfying thing, which is like cancel out. Cancel out, cancel out, cancel out, cancel out. Okay, did you see any pattern? Look, I only canceled out the like terms. If you have something up and down across, you can cancel them out, okay? If not, you cannot do it, okay? So what are you left with? In here at the top, you have 1. At the bottom, you have 1. And in here, you actually have x plus 7 at the top, and you have 7 at the bottom. So we multiply across now. So x plus 7 times 1 gives you x plus 7. And at the bottom, you have only 7 left, and then there's 1. So 7 times 1 is 7. Can you simplify this anymore?
No.
You cannot simplify this anymore. I'm super glad and super happy that you did not tell me that, oh, you can cancel out the 7s, because I can't, right? Yeah. So that is my answer. That is my simplified answer. It cannot be simplified anymore, and hence this is my answer. Okay? So now let's work with the second problem.
20a squared minus 100a.
Also, I wanted to thank you, Zarif, so much for attending to this class after a tiring Friday and obviously an exhausting week. Thank you. I hope you'll find it helpful. Okay, so what do we do? Let's go. What do we do?
Okay, let me try to remember.
Okay, I'll give you like 2 minutes to work on this problem, and then we're gonna work on it together. Okay?
Alright.
How far did we go with the second problem?
I'm trying to factor it.
Okay, like I said before, if you have any questions, if you are stuck, if you're confused, ask me and I will help you out, okay?
Alright. Wait, I forgot. What do you do after factoring them?
Oh, after you are done factoring, right, you look for common factors. So if you have something at the top, at the bottom, the same identical thing, and if you also have them like across, you like look for common factors.
So for it's 16a cube minus 80a square. I found if you multiply 20 multiplied by 4, I get negative 80, and if I if 20 subtract 4 is 16, so it goes with the thing.
You're talking about this?
Yeah.
Well, for this particular expression, right, for this binomial, you have a GCF. So you have to factor out the GCF for this one. I mean, just by like kind of eyeballing it, right, you already see that you have 16 and you have 80. There's something they have in common. So you have to find the greatest common factor that both of these terms have, and then you factor that out. I mean, even though it's like, it looks like, this is a binomial, it's so tempting to think that, oh, it's probably dots, or probably a difference of two perfect cubes, but it's actually not. So the thing that you can do to simplify or factor this expression or binomial in here is to factor out the GCF, and there is actually a GCF.
For the 20a square minus 100a, the GCF is I can divide it by 20 on both with 20 I get 1, so minus 50. 1a square minus 50a.
So if you have a square and then if you have a, do they have something in common? So if you have a squared and if you have a's, there's something they have in common.
I mean, they are in common.
Right. So you can factor the a out. GCF is the greatest common factor, right? So you are looking for the biggest term, right? As long as you have something in common, like you are not done with GCF, like you're not done with factoring out the GCF as long as you have something that the two or whatever, how many variables you have in there, as long as they have something in common, you have to factor that out. You have to take that as your GCF.
Wait, so how do I take the variables out?
Gotcha. Let's work, okay? Alrighty, so we are gonna work on the second question now. So for the second question, you are supposed to simplify this radical expression and you are supposed to multiply. You can only multiply, you can only multiply across, but you cannot do cross multiply, right? So for that, if I'm trying to do that, our best bet would just be to like simplify the top. By simplify, I mean factor the top, factor the bottom if it is factorable, and then look for common factors, cancel them out, bingo, answer. Let's look at the top. Is this factorable? Well, yeah, because I see there's a GCF, right? So my GCF, what is my GCF for the top? GCF is the greatest common factor, so what is the greatest term or monomial that goes evenly in both of those terms? Say it.
20A.
Yup. So 20A is actually our GCF. And how did we figure that out? Well, if I'm looking at 20 and I'm looking at 100, the GCF is actually 20, right? So 20 is the greatest number that divides 20 and 100 evenly, right? So I put that, and I also know that my GCF has to have a variable with it because both of my terms, they have a variable with it. And if you are trying to like look for like, let's say these are my two coefficients, right? So one is a squared, the first one is a squared, the second one is a. And if you are trying to find the GCF of a variable that has exponents, always try to pick the variable with the lowest exponent. So if I have a squared and if I have a, the variable with the lowest exponent is just a, right? So that's why my GCF is 20A, okay? Okay, already. So if I figure that out, I'm supposed to write my GCF in here. Now I'm supposed to divide each of the terms using the GCF. 20A squared divided by 20. So this is my first term. This is my GCF. Well, I see 20 as my common factor, right? So boom, cancel them out. And then a squared, I'm just left with a squared at the top, nothing at the bottom. So it's just a squared. Oh, sorry. My GCF was actually 20A. My bad. So 20A, well, still the 20s cancel out because I have 20 as my common factor. So I canceled the one at the top, I canceled the one at the bottom. And now a squared divided by a is actually a because you have two a's at the top, one a at the bottom. So now a is my common factor. I cancel them out. I'm just left with one a, right? So a is my factor, not a squared. So I write that here. So I was left with actually a, right? So I'm going to write that here. And now let's look at the second term. It's actually negative 100a. And if I divide it by with my GCF, which was 20a, I'm supposed to get negative because a negative number divided by a positive number gives you negative. So then I have negative, and 100 divided by 20 is 5. And I do not have, and I do also have a as my common factor because there's one at the top, one at the bottom. I cancel them out. I'm just left with 5. Okay, so I'm going to put that here. Boom, I'm done factoring the top. Okay, so now let's go to the bottom. At the bottom, I have a minus 1. That cannot be factored anymore because that is the factored form. So I'm just going to bring that down like it was given to us originally, okay? So now let's look at the second fraction that we have in here. Let's factor the top. The top is just 1, like bring it down like it was. Let's look at the bottom now, the denominator. Well, the denominator, I see that 16. I see 16, so now I feel like, oh, that probably is dots because 16 is actually a perfect square. 4 squared gives me 16. I also know that 2 to the third power gives me 16, so it could also be difference of perfect cube because I also see a to the third power. So like these are all my like primary thoughts that hit me when I saw this expression initially, okay? But the problem is the second term. The second term, that is not like a perfect square. Even though a square is a perfect square, 80, that's not a perfect square, right? So I cannot do dots. I also cannot do. Oh, perfect cube is not also gonna work because 80 is not a perfect cube. So you do not have a number that if you multiply 3 times will give you 80. How do you double check that? Well, use your calculator. Do cube root of 80. What does that give you? So cube root of 80 gives me 4.308869. Well, that is not a whole number. So there's no, like 80 is not a perfect cube, okay? So then what are we gonna do? We cannot do dots, we cannot do difference of perfect cubes. Well, then we are back to our good old friend, GCF. Because if there's nothing else you can do, then you are supposed to factor out the GCF and that's it, because you cannot do like any other types of factoring with that expression, okay? So what is the GCF of 16a cubed minus 80a squared? Well, I know the GCF has to have a number with it because both of the terms have a number. And what is the GCF of 16 and 80? You said it correct. It's 16. Because 80 can be divided by 16 and you get a whole number, which is 5. It was negative 80, so you get negative 5. So you can divide both of the terms in there evenly using 16. Hence, that is your GCF, okay? So I'm going to put 16 in there. So if my GCF is 16, is it going to have any variable or not? I know that it's going to have a variable, and how do I know that?
Because negative 80 has the least variable with exponent, which is a squared.
Yep. So what, yeah, so both of these terms, right, they have a to them. As long as all the variables, not variables, all the terms in an expression have something in common, that is gonna be your GCF. That's gonna be at least part of your GCF, right? So they both have a in common. There's a variable in common. So I'm gonna take the variable. Well, now I see that the variables, they have exponents to them. And I already told you guys that when you are trying to determine the GCF of a variable with exponent, you take the variable with the lowest exponent. In this case, the variable with the lowest exponent is, you guessed it right, a squared. So I'm going to put a squared outside because that is my GCF now, right? So once you do that, you are supposed to divide each of the terms of this expression using the GCF, which was 16a squared. And what happens if you do that? I'm glad you asked. So if I'm trying to divide 16a cubed with the GCF, I should be left with 16a cubed divided by the GCF, which is 16a squared. I should be left with the 16s cancel out because 16 is a common factor. I have 16 at the top, 16 at the bottom, boom, they cancel out. So how about the variable? Well, for the variable, law of exponents suggests that if you are dividing two variables that have the same base but different exponents, then you're supposed to keep the base, subtract the exponent. But that is something we're going to learn a little bit later. But for now, if you do it like this way, you have 3 A's at the top, 2 A's at the bottom. You know that, you're going to have 2 A's as your common factor, right? So you can cancel A out, right? And you're just going to be left with A, right? If you do it that way. So then you're just left with A because 3A, because the 2 A's from the bottom, they're going to cancel out. And then the 2 A's from the top are going to cancel out. So you'll be just left with A, right? So which is what I'm going to write in here, okay? Once I do that, I'm going to now go for the second term that we have in here. The second term is negative 80. And negative 80a squared. And if I divide it by the GCF, a squared, what am I left with?
Negative 5.
Yep. You are left with negative 5. Well, how did that even happen? Okay. So negative 80 divided by 16. That gives you negative 5. Because guys, remember, negative divided by positive gives you negative, right? So you will have to, that sign will be retained and you'll have that sign in your final answer. now let's go for the variables. I see a squared at the top, a squared at the bottom. Boom, they cancel out because a squared is a common factor, okay? If you have something at the top, it's the same identical thing at the bottom, they cancel out, right? So -5 is the other factor. Okay, so now that we are done factoring the top and the bottom for both of the fractions, we are supposed to do what? We are supposed to, you guessed it right, we are supposed to do figure out the common factors, okay? So the common factor for the top is actually, I mean, what are the common factors? So, well, let's look. 20a, I do not have 20 anywhere. Like, I do not have the exact number 20 anywhere, but I can see that 20 and 16, they have common factors. They do have common factors, okay? So we are gonna come into that a little bit later, even though that should have been the easiest thing that you should get, because 20 divided by 16 actually gives you what? 4 is the greatest common factor for both of them. So if you divide the top, so you divide the top by 4, and if you divide the bottom by 4, you should be left with 5/4. This cannot be simplified anymore, and hence that's your answer if you do it a little bit like individually from the expression. So I can cancel 20, I can cancel 16, and I can write 5, and I can write 4, because I know they both have 4 in common, right? 4 is the greatest common factor that they have, and once you figure out the greatest common factor, remember you are supposed to divide each of the terms using the greatest common factor, which was 4 for us, okay? Now let's look at a. Do you guys see any other a's in the expression? Remember, the a cannot be attached to something else in terms of being added or subtracted. The a has to be just by itself. It cannot be added to anything or subtracted from anything, okay? Do you guys see any other a's? Just like lose a's by itself. It can be multiplied to something, but it cannot be added or subtracted from anything.
Yeah, it's 16a squared. 4a
and where's
squared.
the other a?
A minus 1.
No, I'm asking you for.
Yeah.
I'm asking you for common factors.
For a, right?
Yep.
No, you asked.
Yep. No. I'm asking you, where do you see? I told you that you cannot have that a added or subtracted.
Yeah, that's
from
why
anything.
I said a squared with 16a squared.
And where's the other a that you see? So I'm asking you.
28.
Yep. So which is now like 5a. So there's an a here, and there are actually 2 a's in here. So you do have a as your common factor, okay? So the a from the top is going to cancel out, and one of the a's from the bottom is going to cancel out. So I'm going to cancel the exponent. So you are just left with a, okay? So you are left with a. So now we're gonna simplify that later, but yeah, we have canceled out a. So now you do not have any other a's, like lose a's, I would say, which is probably not a mathematical term, that is not subtracted from anything or added to anything, okay? Now let's look for like expressions, okay? So now you look for like if you are trying to find a common factor of a binomial, you should look for another binomial, okay? So a minus 5, do you guys see any other a minus 5 at any other places of this expression other than where it was found?
Yes, it's with 5, 20, how should I say? Yeah, it's at the top left and bottom right.
Thank you. Yes, so this actually is, there's an a minus 5 here, and I also see a minus 5 here. So bingo, I have a common factor, right? So when we have common factor, we cancel them out. Right? So once we do that, now let's look for other common factors that we potentially might have. A minus 1, do we see any other A minus 1s at any other places of this expression? Well, I can't see any. You guys can't probably see any either. Well, then it probably does not have any other common factors. And this expression is probably not simplified, okay? So now what we have to do is like multiply across. Remember, you can multiply across, but do not cross multiply. You can only cross multiply equations, but not expressions. So expressions, they can only be multiplied across. And for equations, you can cross multiply. Okay, please do not get these two mixed up, because if you do, it's gonna be a problem. Okay, you're not gonna end up with the right answer. Alrighty, so now let's multiply across and see what we have left. Okay, so on the let's multiply the top. What do we have at the top? We have 5. I see 5 in there. Great, 5, and I see 1. So 5 times 1 gives me 5. And now let's look at the bottom. I have A minus 1, that entire binomial. So I'm going to put that. And I see in this part, I see 4. Remember, there's this 4. And there's this A that's embedded in there. So I have 4 times A. That gives me 4A. If I multiply across, that's what I get. Is that the correct form, or am I done? Or is that the simplified form? Should I leave my answer like that? Why or why not?
Yeah, that's the simplified form, but then 2 parentheses.
Yep, that's what I was looking for, because this is like not even close to what this is.
Yeah, this the first one is like 4A squared.
Yep. That's the thing with algebraic expressions. So if you are trying to like write something like, okay, so let's say that's what you wanted to originally write. But if you write it like this is a whole different thing than whatever you meant. If you do not have that parenthesis, the parenthesis means that you have whatever is outside the parenthesis, you have to distribute it into everything that is inside the parenthesis. But if you get rid of the parenthesis, only the term, or only whatever is like adjacent to whatever was meant to be outside, only that gets multiplied, right? So please keep in mind, if you have a binomial, right, like any other thing that is not a monomial should have a parenthesis around them, okay? So now that is actually our final answer, which is the simplest form that cannot be factored anymore. Please do not distribute the A, like 4A, please do not distribute it, because if you do that, then you're just back into the same loop where you have to factor the 4A out again. You're just like, you know, going back, okay? Because you were asked to simplify. You're supposed to factor, okay? Do not redistribute stuff, okay? Alrighty, so now let's move on. I have some other practice problems for you guys to do. So I have one here, another here. I'm gonna give you guys about, I would say, 7 to 8 minutes to work on it. And once you're done, we are gonna go over it together. Okay, overtime's up. Let's work on it together, because together is better. Whew, the first one looks like a lot of work. Alrighty, so what are we supposed to do? We are supposed to factor the top, factor the bottom. Let's go. So I can't see that it is a binomial, but I do not see it to be like, you know, difference of 2 perfect squares. I do not see it to be difference of 2 perfect cubes, right? So I cannot do any of those special forms, methods. I just have to go with our old school way of doing GCF. We all love that. Oh. So what is the GCF?
21x.
So my GCF is 21x. And how did we figure that out? Well, I know that if there's a 21 here and if there's a 21 here, that is the easiest thing to figure out. That 21 is going to be your GCF, because if you have two things in like two identical things rather in two different places, they're the same thing. That's your common factor. So factor that out, make it part of your GCF. Well, I did. I made 21 part of my GCF. And how did I get the x? Well, I see my first term has x squared and my second term has x. And if both the terms they have x in them, well, then probably x is gonna be in my GCF. And now, like I said before, if you have x squared and an x, if you have variables with exponents in them, please pick the variable with the lowest exponent. So in this case, it's x, okay? So 21x, that's my GCF right here. Divide each of the terms using the GCF, and what do I get? If I divide the first term, which happens to be 21 squared, x squared, sorry. If I divide that with my GCF, what do I get?
X.
Yep, we get x. How did we get x? Well, 21, they cancel out because 21 was a common factor. I have one at the top, one at the bottom. They're supposed to be canceled out. I have x squared and an x. Like I said, if you do not know the law of exponents yet, just do it this way, x times x, because x squared is x times x, and then you divide that by x. If you have one x at the top and another x at the bottom, they're supposed to be canceled out because x is your common factor. So you are just left with x, okay? I hope that made sense. And x is the thing that you get if you divide 21x squared by x, right? They cancel out and we're left with x. Alrighty, let's go to the second one. Well, I know my GCF is 21x, and if I divide 21x by 21x divided by 21x, I get 1. Cancel, cancel. The same thing at the top, same thing at the bottom, they cancel out. I'm just left with 1. Let's go to the bottom part. Well, the same thing. I cannot do dots, or I cannot do difference of perfect cubes because that expression is neither of them. Okay, so we are supposed to use, I hear you calling out, is GCF. Yes. Well, what is the GCF supposed to be? What is my GCF already?
18x.
18x is my GCF. How did I get 18x? Well, the thing is, you have 18 here, you have 18 here. Like the top, if you have 18 in two places, that is 18 is your common factor. So put it in your GCF. Okay, so I have 18 here. And then I see x squared and x. Like I said, in here, if you divide x squared by x, I'm sorry, no, that's gonna be for the second part, sorry. So if you have x squared and x, you pick the variable with the lowest exponent, which is x, and you get 18x. So I write it here as my GCF. Now I divide each of the terms using the GCF. Well, if I divide my first term, which happens to be 18x squared by 18x, 18 cancel out. And if there are two x's at the top, one x at the bottom, follow this thing, you are just left with x. And now it's the same thing as we did for the top. You divide negative 18x by 18x, and you are just left with -1, which is what goes in here. And now let's look at the second fraction that we have in here. The second one looks kind of like, you know, a little less scary. Halloween season, spooky. So in here, well, there's nothing much that I can do because I cannot factor them. I mean, if you want, you can like put x times x in here to kind of like, you know, expand it. So now what do we do? What is the next step that we do?
Cross out the like terms.
Ooh, I like the term. It's like terms. Ooh, that's fancy. What are like terms? Well, like terms are terms that look alike. Duh. Well, like terms, she mentioned about like terms. Okay, so now we look for actually common factors, or you can call them like terms. I see a lot, like it's filled with common factors. I have x minus 1 here, I have x minus 1 here, so I can cancel them out because they're my common factors, or in other words, they're like terms. Well, here's the thing. I'm not sure if I can call x minus 1 a term because there are actually 2 terms in here, which makes it a binomial. So a more preferable term to use is actually common factor, okay? But now you can like use the term like terms because now you are just left with monomials, okay? So you have x here, you have x here. They are like terms, in fact, so we cancel them out, right? Because they're also like common factors. So now let's look at the other part. Remember, guys, canceling, it just like depends on you. There can be like factors everywhere of the expression. It's you figure out which order you want to do it, right? Like, I mean, I can't like tell you, oh, you have to do it across first. You can do it whichever way you want to do it. You can do top, bottom, you can do across, like top, like whichever way you want to do it, okay? Now look, if we go to this one in here, I see x at the top, x at the bottom, they're like terms, boom, boom, cancel out, right? I see 6 at the top, 6 at the bottom, like terms, boom, boom, cancel out, okay? Now I have left 21 and 18. Do 21 and 18 have a GCF, or do they have anything in common? Outside the GCF, rather. What is the GCF of 21 and 18? It's 3, okay? So now we divide each of the terms, or each of the terms is the GCF. So 3 divided by 21 gives you 7. 3 divided, I apologize. 21 divided by 3 gives you 7. 18 divided by 3 gives you 6, right? So now what do? We now multiply across the things that we have left, okay? It shouldn't be hard. We have 7 left from the top, and 6 is the only thing, not the only thing that we have, but like the only thing that we have left from the left fraction. From the right, we have x. 6 times x gives you 6x, and that is your answer. That this fraction cannot be simplified anymore, so that is your simplest form, okay? Now, moving on to this question. That looks like something. Gives me a bad feeling. But if you know your factors, like, you know, how to factor polynomials, it shouldn't be hard. You know this. Okay, let's go. Ooh, what kind of polynomial is the top?
Trinomial.
Yep, it is a trinomial. Because there are 3 terms, 1, 2, 3. If there are 3 terms, it's called a trinomial. And how do you factor trinomials? There's really a type of factoring known as trinomial factoring, which is what you are supposed to do for the top. Okay, so how do we do trinomial factoring? We're going to end up with 2 factors, and the first term that goes in those parentheses is the variable. So what is the variable we see at the top expression? I see X, and I'm pretty sure you see X as well. We put X in there. Now is the interesting part. We have to figure out two numbers that will add to -8 and two numbers that will multiply to +12. It's kind of like the trial and error method where you have to like check different numbers and come up with those two perfect numbers that we are looking for that will add to -8 and multiply to 12. Well, I don't know, but I would say the thing that I personally do is I try to find the factors of 12. Okay, so what are the factors of 12? I'll use the space at the top. So factors of 12 is 1 times 12 gives you 12. 2 times 6 gives you 12, right? Well, at that point, you should be asking yourself, well, here's another thing, here's another clue that I'm going to tell you guys about. When do you get a positive product? By product, I mean, when do you multiply two things and get a positive 12? Or in other words, what I'm trying to ask you is that what should be the signs of the two numbers that you should multiply to get a positive product?
Negative times negative.
And what?
Positive times positive.
That's correct. So positive times positive gives you positive. And positive times and negative times negative gives you positive, okay? You see 1 and 12, there's no way you can get 8 from there. Even if you add 1 and 12, even if you subtract 1 from 12 or 12 from 1, you are never going to get -8 from it, okay? Then let's go to 2 and 6. Is there a way you can get 2 and 6 to add up to -8? Well, I mean, you should be asking this to yourself. So starting from the first factor, right? Every time you figure out the factor of your constant, you should be asking yourself, you should essentially be asking yourself, oh, is the first factor, can I do something to the first two factors so that they will add up to whatever I'm trying to figure out, right? Like if that will add up to the middle coefficient, you should be asking that to yourself, okay? Well, for me, the first two numbers, right? 1 and 12, 1 times 12 gives me 12, but then I can never make them, like, I can never, like, even if I change the signs, I cannot make them add, or I cannot, like, add up to -8, or I cannot, like, subtract one from the other and make them equal to -8. That is not going to work. Well, if that is not going to work, let's go to the second pair of factors that we have. Can we make 2 and 6 equals to -8 by using the word make? I mean, can you like play around or switch the signs of them to get them to be added to -8?
Yes.
Yep, the answer.
-2 -2 and -6.
So -2 minus 6 actually gives you -8. If you want to do it the other way around, do it the other way around, like -6 minus -2. That also gives you -8. It doesn't matter the order you put the numbers in. So both of my numbers will have to be negative in this case. Well, for the first one, I see to like check out, right? How about the second one? Does -2 times -6 gives you +12? Yep, it does. How does it do that? Well, if you are trying to multiply two negative things, like we said earlier, it gives you a positive product. And 2 times 6 is 12, okay? So my two numbers are -2 and -6, which is what I'm going to put here. It doesn't really matter which number you put first, but it's recommended that you put the bigger number first, okay? Oof, done. Oh, the denominator. It looks something to me, like it looks special to me. And why is it special to me? Well, it's special to me because I see x squared and I see 16, and they're subtracted. 16 is subtracted from x squared, so they're separated by subtraction. So what is that? That's a special form of factoring. What kind of factorization should I do for that?
Dots. Difference of two perfect squares.
Yep. Thank you. We're supposed to do dots. Difference of two perfect squares, okay? So let's do it. So if I'm trying to do dots, then I should put the variable first. Yeah. And then, I should have two factors. Variable is the first thing that always goes in the parentheses as the first term. And then what is the 16 is a perfect square, and then what are the two numbers that you should multiply to get 16? What I'm asking is that if 16 is a perfect square, what is square root of 16?
4.
Yep, so square root of 16, you actually get positive and negative 4, which is why you're going to write positive 4 here and negative 4 here. Okay? So then once we do that, we are done with our first fraction. We simplified it by we factored it, okay? Now let's go to the second top, or the top of the second fraction. What do we see in there? Well, I see 4x that is being added to 16. What should I be doing to that to factor that? I can't do like dots. I can't do like different like perfect sum of perfect cube. I can't do any of those. So then I have to do GCF, because if you cannot do anything, you should always be able to do GCF if it is factorable, okay? 4 is my GCF. Why don't I have a variable with my GCF? Well, I don't have a variable with my GCF because not all the terms have a variable. 16 doesn't have a variable, so I can't have a variable with my GCF because the variable is not a common thing, okay? So for parentheses, so now we divide each of the terms using the GCF. So 4x divided by 4, 4's cancel out, left with x, and 16 divided by 4 gives you 4, x plus 6, x plus 4. That is the factored form of your top. Now let's go to the bottom. Oof, the bottom is again, a trinomial factoring, okay? We just did it. We just did it for this, okay? So how do we do that? We figure out the two numbers that will add up to the middle coefficient, and the two numbers should multiply to the constant that we have in there, okay? So what are the two numbers, and how do we figure that out? Well, I know that the variable goes first, so x is going to be my first term for both of the parentheses that we have in here, okay? So how do we figure out the two numbers? Well, like I said before, what I like to do is I like to find the factors of the third of the constant, okay? So what are the factors of 4? 1 times 4 gives me 4, okay? 2 times 2 gives me 4. So now I should be asking myself, what should I pick? It's an easy one because I only have 2 pairs of factors, and it's like easier to do the trial and error thingy. So now I also know that the only time I'm going to get a positive product is if I multiply either 2 negative numbers or variables, or 2 positive numbers or variables, okay? So can I make 1 and 4 ever add to negative 4? Can I negate each of those numbers and make them add to negative 4? Can I ever do that? So what I'm telling you is that can 1 plus 4 give you negative 4 ever, or can negative 1 minus negative 4 ever give you negative 4? No, right? That doesn't work out. Well, then the answer, right? The last piece to my puzzle should be probably this one. 2 and then 2, okay? 2 times 2 gives me 4, but what should I do to those two numbers to make them add to -4? I should negate them. Let's negate them. -2 plus -4, which in other words is just -2 minus -4. I mean -2 minus 2, which gives you -4. -2 -2 times -2, does that give you +4? Yes, that does. Check. So my two numbers are actually -2, -2. You can also write this thing as this, but since you are since you are trying to find you will be looking for the common terms, I recommend not to do that because sometimes it gets hard to see the exponent. If it's expanded, then it's kind of like easier to observe and then pick out the common terms. So now let's look for common terms. What are the common terms? Well, let's go with the first binomial that we have in here, x minus 6. Does that binomial appear in other places of this entire expression? I do not see it. Nope. Thank you. How about x minus 2? Does that appear in other places of this expression? Yes, it does. It appears in here. It appears in here. So then those are common terms. We cancel them out. Well, you could have canceled out the first one as well. It does not matter which one you cancel out. You can do either one. And then let's look at the bottom, right? X plus 4. Do we see any other x plus 4s in any part of this expression? Yes, we do. One here, another one here. So they're common terms. Cancel them out. X minus 4. Well, no, I don't see x minus 4 anywhere else. Let's go to the second part of this expression, which is this. There's a 4 up top, but then I do not see any other 4s or any other factors of 4, so I cannot cancel that out. I'll have to leave it like that. And then we have another binomial at the bottom, x minus 2. I do not see any other x minus 2s, so that it will have to stay in there. So now what do? We multiply across. Already, so we multiply 4 and x minus 6. I'm just going to put a parenthesis around x minus 6 and not distribute the 4, leave it like that, because I'm asked to leave it in factored form. Now I have x minus 4 at the bottom, x minus 2 at the bottom. I'm going to put them together with parentheses, them like being multiplied together. Please do not combine this, like do not distribute, do not do FOIL and any of those. Leave it in this form because you are being asked to simplify, because if you do that, then you are just looping back to whatever you started with. You are not asked to do that. Okay? So that's it for today, I think. Yes, so that's it for today. We are going to learn about dividing rational expressions tomorrow. So I'll see all of you tomorrow. Till then, take care, stay safe.